Okay, let's finally jump all the way into this and work our way through a full partial fractions problem. Okay, so first step is to do the side work algebra problem that we've been talking a little bit about already. So this is the fraction I'm working on. That's not incredibly straightforward to just go ahead and integrate. So what we want to do is break it into simpler pieces. So this again is just side work. It's an algebra problem. We'll separate it off. If we want to end up with a common denominator x minus 4, x plus 4, we better have started with denominator x minus 4 and x plus 4 showing up in our simpler fractions. And then the question is, what should the numerator be? And since the denominators are both first degree, the numerators both have to be constant. So this is my setup for partial fractions. The actually finding the values of a and b, not that bad, I promise. I'm going to show you a couple different tricks. At first, sometimes the second trick seems a little weird, but just algebra tricks, and I think you'll feel good about both of them after just a little practice. So what I'm going to do here is clear fractions. So I'm going to multiply both sides by the LCD. And the same thing over here. And what happens is on the left-hand side, I'm just left with the 1. On the right-hand side, when I multiply the a over x minus 4, the x minus 4's cancel. I'm left with the x plus 4. The b over x plus 4, the x plus 4's cancel. I'm left with the x minus 4. So basically we're just, what's happening here is if we built up a common denominator on the right hand side and then just crossed out all the denominators, we're comparing the two numerators. We want them to be equal. Okay, so what happens from here, at first is a little weird to people, but it's very easy to do. So here's the deal. We want this to be true no matter what x value we choose. So we're not trying to find the value of x that makes it true. We're trying to build an equivalent expression, meaning it's true. We want to build an identity here, a statement that's true for any x. That gives us some freedom to do some kind of tricky things, one of which is just picking convenient x values. So here, I'm going to let x equal -4. And this could be anything. So since you have free choice of what your x can be, you should choose something that helps you solve for either a or b. It's the value of a or b that we're looking for. X can take on any value. So if I let x equal 4, the left-hand side is still 1, but now the right-hand side, I get a times 0 plus b times -8. So the a is gone. If I divide both sides by -8, I find that b has to equal -1/8. So this is like easiest possible scenario. If you just have a bunch of unique linear factors, you can just wipe them out one at a time to try and get some information. We also want to find the value of a. So if we look and say, okay, how would I make the b's drop out? My answer is that, let x equal +4. Again, the 1 on the left is always a 1. So we have 1 on the left, and then we have a times 8 plus b times 0, which goes away. And then if we divide, we get a is +1/8. So this was the whole partial fractions trick. Be very careful with your arithmetic and your algebra, because if you mess that up, everything's going to be wrong. But what we just found out is that if we want to integrate 1 over x minus 4, x plus 4, that's the same as integrating 1/8 over x minus 4, and then -1/8 over x plus 4. So I'm just looking back at my partial fractions right here, and now that I know the a and b values, I just plug them in and replace my original fraction by the two simpler fractions. If I was trying to write a final answer, I'd probably just move the 8's into the denominator and say I have 1 over 8 times x minus 4, but for integrating, I actually think it's easier to keep it on top and think about it as my constant. So first, I'm going to have a 1/8 hanging out, and then I want to think about What is the antiderivative of 1 over x minus 4? And there is a really basic composition happening there. It's not just 1 over x, it's 1 over x minus 4. But when it's just a shift like that, when it's just a linear function plugged in, those are really easy chain rules to think your way out of. If you want to do a substitution, you can, but I really encourage you to look at that and say, okay, it's a 1 over x function that's just been shifted to the right by 4. So its antiderivative should be a natural log function that's also been shifted to the right by 4. And then the same thing with the negative 1/8, leave it out in front. If we want to integrate 1 over x plus 4, we're going to get the natural log of the absolute value of x plus 4, and then a plus c. This is our answer. The only thing I want to make a big deal about with that not using substitution to work your way out of the chain rule is don't go on autopilot and assume that every time you have something in the denominator, you will get a natural log. If we had a 1 over x minus 4 squared, remember that's x minus 4 to the negative 2. So the antiderivative would be an x minus 4 to the negative 1 divided by negative 1 or multiplied by. So unless it's a first power in the bottom, you're not going to get a natural log. It's only for first powers that works.